We've been finding the sides of triangles using trigonometry. This time we want to find an angle. So what we're going to look at, we're going to have our angle here. And then what we're going to do is we're going to start trying to find what ratio matches up to this angle. So if we have a look here, when we go to do some equations with this one, if we have a look, we've got our opposite side and we've got our hypotenuse. So if we remember our SOHCAHTOA, that would mean that our sine would be opposite over hypotenuse. So the sine ratio is the one we're going to deal with in this problem. So if we have a look at how we set it up, so remember we decide which ratio we deal with first, and then we start to go, okay, well, let's set up our ratio. We've got sine theta equal to 3 over 7. So that's the opposite side over the hypotenuse. So we want to solve this equation now. So our unknown is our value of theta there. So we have to do a special operation this time, and we've got to basically go the opposite of taking sine. And the opposite of taking sine is what we call the inverse sine. And we indicate that with a little value of -1 above sine there. So when we see that, that means inverse sine, or the opposite of sine. Now, we know on our calculator to find sine of an angle, we use our sine button. So I haven't got a real calculator to use on the screen here, so I'm using just a picture, but it's okay because it tells us what buttons to use. Now, above that, if you have a look on your calculator, because this is the same as yours, there's a little yellow inverse sine notation there. So what's that saying is that basically we're going to use our second function. So push our shift button and then push the sine button there. And that should bring up that inverse sine on your screen. So you should see this statement here. If you type in 3/7, then what we need you to do is to go and push equals, and it should give you that number. So what it's saying here is that theta is equal to 25.3769, and it'll go on, degrees. So it gives us that whole number there. And what we want to do is, our accuracy is not that great that we need, so we're just going to round that to the nearest whole number, which is going to be 25 degrees. That's as good an accuracy as we really need it for our problems here. We can work on going a little bit more in detail with our angles later on and getting in degrees and minutes and seconds if we need to. But that's as good as we need to do at this stage. So what we're going to do, what we need to do, keep in mind, look for the sine is equal to the opposite over the hypotenuse. So decide your ratio first. So with the angle in the two sides, set up your equation like we've done before, except we had an angle and we have one of the missing sides, but this time we're missing the angle. So our operation is to take inverse of that trig ratio. So sine, cos, or tan, in this case it's sine, and put that ratio in. So input that line into your calculator, push equals, and it should give you that, and we round it off to 25 degrees. Let's have a look at another example. So in this one here, we can see we've got our angle alpha. Alpha and theta are just Greek letters, and that's what we usually use for angles. So it can be anything we need, any variable we want, but generally angles are we use Greek letters. We decide our sides that we're going to use. So if we have a look at our angle, this side would be the opposite, and this side is the adjacent. So hopefully we're thinking, hey, that must be the tan ratio, because SOHCAHTOA. So we're going to use the tan ratio in this case. So we set up our equation. So we go and set it up. Tan theta is equal to the opposite side on the adjacent side, 16 over 12. So tan ratio, opposite over 12. And to get the alpha by itself, we would take the inverse tan. So inverse tangent of 16 on 12. So again, we go back to our calculator, and this time we're going to push the shift button because we want our inverse button, and then we're going to use the tan. So notice the little tan, -1, that's the operation will give you, and that's what you should see on the screen. You put that angle in, that ratio in, push equals, and it gives you an angle of 53.130, and it keeps going. And then again, let's round it off to 53 degrees because we don't need any greater accuracy than that at this stage. So in summary, what do we need to do? Determine our angle. Determine where our angle is and what ratio we've got. whether it's sine, whether it's cosine, whether it's tangent ratio. Then set up our equation as we would normally do. Again, we're going to solve for whatever variable is. We've got 3 unknowns in our triangle at most times that we need to put in. Put 2 in to get the third one. So inverse tan, 16 on 12, into the calculator at this stage. So we put that into the calculator, and then we're going to get that angle there equals, and then we're going to get to round it off. And that will find the angles for us given two sides in a triangle.